Concept 11, our 8th test of the year on these concepts. First question is, what's the vertex of the function? So we've got to go try to figure that out. I don't like where the negative 3 is. I don't like where the negative or the 3 is. The first thing I'm going to do is rewrite this. So instead of negative 3x plus 2, I know inside an absolute value I can change all the signs without changing the value that would come out of the absolute value. So I'm going to do that first. And then I don't want to see a 3 here. I just want to see a 1x. And then whatever happens, I'll be able to determine what the vertex is. So what I can do there is I can take out the 3, kind of like I'm factoring it out. And then I'd have x minus 2/3. And then minus the 4. Let's check and make sure I did that right. If I take 3 times x, do I get the 3x back? Yeah. If I take 3 times the 2/3, do I get the 2 back? Yeah. So that factors out correctly. And now I can go ahead and say what the vertex is. The vertex is going to be at positive 2/3 and negative 4. Any questions on that problem? Go on with number 2. It says write 2 linear equations. So that means 2 equations of lines we could use to graph y equals x plus 7. Absolute value of y equals x plus 7. Well, one of them is y equals x plus 7. And the other one is just the opposite of that. Y equals negative x minus 7. Those are the 2 equations we're looking for there. Any questions there? So 12, graphing linear and absolute inequalities. We have to graph this absolute value. So luckily we just have an equals. We don't have an inequality, so this makes it a little easier. We've got to find the vertex, which is probably the hardest thing. And then from there we can draw the graph. To get the vertex, I'm going to have to get that 2 out of the way. So it's going to give me an x, and then plus. If I took the 2 out, I've divided by 2. Or factored out, it's going to give me a 3/2. So when I look at that, I know my vertex is at negative 3/2, comma 0. So I've got to graph that. Go ahead and put my x and y axis on the graph paper. Find negative 3/2, negative 1.5, comma 0. Negative 1.5. This is negative 1. This would be about negative 1.5 right here. I've got the sides are going to have slopes or steepnesses of negative 2. So I would fall 2 and run 1. Fall 2 and run 1. And do the same thing on the other side. And then I could go ahead and sketch in my V-shaped absolute value graph. Remember, when you're graphing an absolute value, you should always get a V shape come out of that thing. Any questions here? Okay, concept 13. Number 4, most of us probably just looked at that and said, hey, I see the 5x and the 5x, let's eliminate. So we'll subtract 5x minus 5x zeros out. That's what we want. We eliminate the x's. Negative y minus a negative 3y is the same as negative y plus 3y, which should be 2y. 5 minus 15 is negative 10. When we solve for y, we get negative 5. Don't stop here, though, because we want to solve the whole system. We want to get the x value, too. So let's take the negative 5, put it back in one of the other equations. So 5x minus, instead of y, negative 5 equals 5. 5x plus 5 equals 5. What does x have to be? Can you see it at this point? Not yet? Yeah, 0. If you don't see it, you just keep working. Subtract 5 from both sides, 5x equals 0, and divide by 5, x is 0. So we found the point 0, comma negative 5 as a solution to number 4. Next one, number 5. Not quite as easy because we don't have the coefficients matching on either the x or the y. So I think what I and most of you probably chose to do was multiply the top equation by 2, multiply the bottom equation by 3 to try to match the y coefficients so they can eliminate. 2 times 5 is 10x. 2 times 3y is 6y. And 2 times a negative 6 is a negative 12. Multiplying the second equation by 3, we get 9x minus 6y equals 12. If we add, the y's will eliminate or zero out, which is what we're trying to get to happen. we get 19x's is equal to 0. Divide by 19x is equal to 0. We're going to plug that value into either equation. Let's go for the second one here. 3 times 0 minus 2y is equal to 4. This will help us find the y. 3 times 0 is 0, so negative 2y equals 4. We divide by negative 2, y has to be negative 2. So we found the point 0, negative 2 for the solution of number 5. Any questions there? On number 6, we're just asked to graph this system. So I'm going to go ahead and use a x and y axis here, right off the middle of the graph paper. Graphing the first equation, I can see that the y-intercept is negative 1. So go ahead and put a point there at negative 1. And I can see that the slope is negative 3. So I'll drop 3, 1, 2, 3, and run 1. And then I'll go ahead and draw that line. What kind of line is this? Solid or dashed? How do I know this one's solid? Because of the or equals, right? It can be equal, so it's going to be a solid line. To do the other equation, I'll start at the y-intercept negative 2. This one has a slope of positive 3, so I'll rise 3, 1, 2, 3, and run 1. I'm going to do that a couple times. And what type of line do I need to draw through these points? This one's going to be dashed because we can't be equal. Okay, I forgot to determine shading on that first line, so let's go back and determine shading. If I pick a point that's not on the graph, I'm going to choose 0, 0, and plug it in. I get 0 is less than or equal to 0 minus 1 or negative 1. Is that true or false? Is 0 less than negative 1? No. So I'd want to shade the other side. The true side would be over here. And then do the same thing for the dashed line. If I plug in 0, 0, I get 0 is greater than negative 2. Is that true or false? That's true. 0 is greater than every negative number, so I want to shade the 0, 0 side. So the shading overlap should be in this area to the left of everything here. On the left of the two lines. All of this. Any questions here? The most common mistakes were forgetting dashed or solid, and then also just missing the shaded region. Number 7 gives us an exam consisting of two parts, a section X and a section Y. Those are nice labels. There can be a maximum of 90 questions. There must be at least 5 more questions in Y than in X. And we're asked to write a system of inequalities to model the number of questions in each of the two sections and then graph that system. So the first thing we need to do is we need to start coming up with some inequalities. I'm going to let X equal the number of questions in section X, Y equal the number of questions in section Y. The part where it says there's a maximum of 90 questions, what's a good inequality for that? X plus Y less than or equal to 90 is a good inequality for that. The next part, there must be at least 5 more questions in Y than in X. Well, let's set up Y and X here. Just playing with this over here in a little scratch area. Y and X. Which one has more questions? Y. So if I want these to be equal, what would I have to do to make them equal if Y has more questions? Add 5 to what? X. Okay, but it doesn't say they're equal. It says at least 5 more. So that means that this is actually, Y is actually greater than or equal to X plus 5. It's at least 5 more. So that's the other inequality, which I could turn around as negative X plus Y is greater than or equal to 5. If I want to line up X's and Y's for work later if I need that. So this is just kind of scratch work. I'm not going to use that in my final answer. What other constraints could there possibly be here? Yeah, can't have a negative number of questions. Any other constraints? Nope, that's all the constraints. So this is, I want that graded. Go ahead and box that up. That's the first part. It says write a system of inequalities to model the number of questions. I've done that. Now the next part is graph the system. So now I've got to go try to graph that system. Since x and y are greater than or equal to 0, both of them, that's going to restrict me to quadrant 1. So I'm going to let the x-axis be at the bottom and the y-axis be on the side this time and just use this whole thing for quadrant 1. I've got some pretty big numbers here. 90 is not a small number to graph with. So instead of going by 1s, I'm going to go by 10s on the x and the y. So I've got 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100 would be the edge of the paper. 20, 30, 40, 50, 60, 70, 80, 90, 100 would be the top of the grid there. To graph x plus y is less than or equal to 90. If x is 0, what's y? 90. If y is 0, what's x? 90. I'm going to go ahead and draw that line. That's a solid line. If I'm graphing less than or equal to, which side would we be shading there? Below. 0, 0 would be true. And I have one more line I got to try to graph here. That's this. Negative x plus y is greater than or equal to 5. So to graph that, I've got to think negative x plus y equals 5. And let's go ahead and set that up in a t-table. If x is 0, what's y? Anybody? How much? 5. 0 plus 5 would be 5. So if x is 0, y is 5. That's about right here. If y is 0, what is x? Negative 5? Which doesn't fit my scale too well. It would be about here. So I'm going to try to find another point that works, because I want to find something that's actually on my grid that I can graph with. So let's say if x was, what if x was 30? What would y have to be? 35. So 10, 20, 30. Let me get this tool. 30. And then I got to go up to 35. 10, 20, 30. 5 would be about right here. Let's connect those dots. This one I may not want to use because it's not on the grid, so it's kind of an estimate. But I know that one is, and I know this one is. Which side do I want to shade here? Let's pick a point that's not on the line, like 0, 50. For sure 0, 50 is not on the line, and put it in. 0, 0 for x, 50 for y. Is 50 greater than or equal to 5? True or false? That's very true. So we're shading on that side, which gives us shaded area in this region, this triangular region here. Because we're forced to the first quadrant by those last two constraints. X is greater than or equal to 0. Y is greater than or equal to 0. Any questions here? Number 8, basically they've done all the work for us. They've graphed a set of equations. They found the vertices for us. And they just want us to kind of finish off a linear programming problem and find the values of x and y that maximize the objective function p equals 3x plus 2y. I saw quite a few arithmetic errors on this problem. You guys mostly had it set up right. But if we're going to check this, we should probably check 0, 0, 0, 8, 5, 4, and 9, 0. 0, 0 is not going to give us much. 3 times 0 plus 2 times 0. 0, 8, 8 times 2 is 16. 5, 4, 5 times 3 is 15 plus 4 times 2 is 8. So that gives me a whopping total of 23. And 9, 0, 9 times 3 is 27 plus 0 times 2 is 0. So that gives me a whopping total of 27. So my maximum occurs at the x value of 9 and the y value of 0. And that maximum value is 27. That's my final answer. Any questions here?